G'day Internet, welcome to Stick Ninjas DevLog episode 30. My name is Andrew Russell, and lately I've been working on prediction errors in Stick Ninjas. So you might remember this bug from episode 27. This one I've now fixed. The problem was basically the client runs two instances of the physics engine, one for sort of the regular world and one for prediction. And this bug was just me not copying the on-ground state back from the prediction world to the regular world. So basically the regular world thought the player was on the ground while he was in midair, and so was allowed to jump, and then he would snap back down when the prediction said, no, actually he's in midair. So that's all fixed now. But as well as this bug, I've also been working on sort of just general prediction errors. See, the problem is, back when the game was just this flat landscape and I hadn't added the physics engine in, if the prediction was wrong, then, smoothing would just slide the player back into place. And, there's ways I can cope with making this a lot sort of smoother. But now that I've added obstacles and platforms and stuff, it's very easy for the client to say, predict that they've jumped onto a platform, whereas the server says, actually, no, you hit the side of this platform and you've stopped, and the client's like, no, I'm keep going, jumping over the top. And so the client and the server get into this disagreement, and the client will flicker around when the server finally catches up to where the client is. And the client's running prediction every time it receives new data from the server. So it's running a new instance of the prediction with the updated data. So it's entirely possible that the client can actually predict it one way on one prediction and a different way on a different prediction. So it just flickers around, even just on the client. And so this is a huge problem because, if the player's flicking around, the people will think that my netcode is terrible. So, I'm demonstrating this on the fail client because it makes it really obvious that this is happening. But this can also happen with a really good connection, and so that's really off-putting if you suddenly jump somewhere, even if you've got like a low ping. So the underlying cause of this is basically the server not simulating in the same way that the client predicted that it would. And I think the main cause of this is the server's using slightly different inputs to what the client's using. And the main cause of this at the moment is jitter in the incoming packet stream. So I've added some new features to the server's debug timing ruler thing. And so you can see here, if I select a client, the server displays information for that particular client on its ruler. So I've added this little red line at the top, which indicates that the server's the last frame that the server received from that client. And then at the bottom there's this magenta line which represents sort of the extrapolated input frame. So basically if the server doesn't receive an input frame on a given frame, it just sort of advances its timer anyway and reuses the previous frame's previous frame's input. So first of all, that extrapolation process will sometimes cause the input to be wrong if it extrapolates, say, a button press, whereas the actual players actually release that button, for example. But the bigger problem is that, as you can see here, the basically the input frame that the server's using is just jumping around all over the place, and that's causing your sort of inputs to have slightly wrong timings on the server. Really, like, this magenta line should basically be in a fixed position relative to the server's current frame, so it just shouldn't be flickering at all, it should be staying put. Fortunately, a system for doing this already exists in the game. The client implements a lag buffer that allows it to still make use of packets even if they arrive slightly later than they should. And last episode you might remember that I was talking about my new timer synchronization system. So I've started the work to port that to the server and sort of just make it more generalized, just enough so it can be used with the input stream. And so I've implemented the packet timing system, and you can see that here. There's now one on the server for each client, and that tells the server where it should be synchronizing to. So I still have to do the synchronization itself and the lag buffer, but the bulk of the code for those already exists, so that should be fairly straightforward. So a lag buffer will go a long way to solving the problem with prediction errors, but it won't eliminate it entirely. It's still possible for the timing to be off, but with a lag buffer, hopefully that should be limited to basically 1 frame in either direction. The other main cause that it doesn't deal with of prediction error is quantization problems, which is where the server and the client have values that are slightly different to each other, and those slight differences in input values result in very different simulation outputs, kind of like a butterfly effect situation. And so there's ways I have of dealing with that particular scenario, but they also require a synchronized input stream, so I'll work on that one first, basically. So that's everything for this week. If you missed my announcement last week, I am doing a new series called Let's Examine, and next week will be Let's Examine Kerbal Space Program. So those slot in between each devlog episode, so look forward to that. Otherwise, as usual, you can visit my blog at andrewrussell.net, or you can follow me on Twitter at _AndrewRussell. And if you go to stickninjas.com, you can sign up to get a notification when Stick Ninjas is available for playable pre-order. Thank you very much for watching, and I will see you next week.